Now, we still have questions from last week to finish up. Okay, so what you can do now is turn on your video, right? Mute your microphone. Yeah. Okay, good. So, Louis is here now. We are only short of 2 students. I think they will come in later, like they did last week. Okay, let's start. Question 10 from worksheet 35, last week's question. So we have physical properties of 3 unknown materials A, B, and C given here. Okay, so the materials, when we look at them, we are looking at the properties that relate to transparency, scratch test, as well as the melting point. So when we look at our table here, okay, opaque means what? Opaque means light cannot pass through. Transparent means all light passes through. Okay, scratch test, if one material can scratch another material. Okay, the first one is actually, for example, if let's say X can scratch Y, X will be actually harder than Y in order to do that. Okay, so in real life, we have diamond being used to cut glass. So diamond is a lot harder than glass. Okay, so diamond is harder than glass, therefore diamond can scratch or cut glass. Now, so in this case, you have A scratches material B, B does not scratch material C, then we have C scratches material A. Okay, so when you are looking at this piece of information, you have to know how to rank them in the right order. So write down something like that beside your table, or you can write, maybe just within the table, scribble something. So when A scratches B, that means A is harder than B. Okay, B cannot scratch C. C must be harder than B, right now. So after that, you see material C scratches material A. So C must be harder than A lah, right now. So C is harder than B, C is harder than A. That means C is the hardest. You can even write down. So the hardest material is C. Okay, so the opposite will then be weakest, right? So which is the weakest one? You see, A is harder than B. C is also harder than B. That means B out of the 3 will be the weakest. Okay, so in between, right, definitely you will have A there. So if you want to make a scratch-proof box, what do you think is a suitable material here? Okay, quite obvious already, isn't it? You want something that is scratch-proof, cannot be scratched. Okay, scratch-proof means it cannot be scratched at all. So it has got to be something that is the hardest. Okay, when you choose the material, you choose C. Reason, it is the hardest amongst the 3 materials. Okay, so out of these 3 materials, we can only choose C. All right, next, test tube. You want to make a test tube. Do you know how a test tube looks like? Have you all actually worked with a test tube? Yes, right. So when you have a test tube, you use it inside the science lab. What do you usually use it for? What do you usually use it for, the test tube? To contain chemicals, right? So you put chemicals inside it. Next, you also do something else for heating small amounts of it, right? So heating small amounts, okay? So one is to contain substances, one is to use it for heating. So therefore, in order to choose the material that is suitable for this, okay, you want it to be able to withstand heating. Withstand heating means its melting point must be very high. Again, like last week, we talked about it, right? Okay, and then Hannah started laughing. We need the drill to actually be of high melting point, right? Because you are drilling tiles, you're breaking down the tiles, you don't want to drill halfway, the drill can't drill anymore because it has melted. Okay, same thing, test tube as well. If you are putting the chemicals in and you are heating the test tube, it must be able to withstand high heat, right? Otherwise, the test will start melting. Then you got nothing else to work with in the science lab. Okay, so it can contain chemicals. You must be able to see the chemicals, right? We want to be able to see the chemicals, and then we want it to be able to withstand heating. We choose material B. One is because it has high melting point. The other one, it is transparent. Now, I even want to add on a little bit more, no? Okay, I will say that material B has a high melting point to withstand strong heating. Okay, it is transparent to allow us to see what changes occur inside the test tube. So usually when we're doing heating, we're trying to see whether that substance change color, whether it breaks down into something else, whether it melts, etc. Nikki, you have a question.
Actually, I have a question relating to it, but before that, my apologies if sometimes I feel distracted. It's because today I took my paper for English, and then I think I was very tired today, and then after that, I came back from school late, and then I couldn't have time to start my work. I needed time to rest a bit. So
What is
earlier,
paper for?
yeah, but the oral paper, my first EOI
Oh,
paper.
oh.
And then some more, the whole day was academic subject, and then when I come back from the because I come back later today, right? I didn't have time to do my work that I want to do, and then I can only do a light work like later, maybe like look through the file or the textbook. That's the.
Okay, can, no problem. Okay,
And then
so,
another question is that
uh-huh.
the melting point, right? Why can't we say like it's a good thermal conductivity? Like, what's the difference between the melting point, the thermal conductivity? Because I remember that melting point was also used for like the cooking pan and all that. But then I suddenly thought maybe the cooking pan also can use thermal conductivity. Like these two terms, how is it differentiate?
Okay, hold on. Let me also Google your question. Melting point in relation to
Thermal conductivity.
thermal conductivity is dependent on the effective flow of electrons to transfer that thermal energy. Okay, these physical properties, melting point and thermal conductivity, are apparently independent of each other. Let me give you one very good example, okay? Let me give you one very good example. Okay, you know a material known as Kevlar, okay? Let me show you. Kevlar is a very strong heat-resistant fiber. It is in fact used for the firemen. Okay, used for the firemen, used for the soldiers, because it is extremely strong and lightweight. It is resistant to corrosion and heat. This is a material that has a very, very high melting point. And at the same time, it does not conduct heat well. Okay, it's resistant to heat. It doesn't conduct heat well. Why? Because imagine a fireman going inside this house that is burning. Fair enough. So the fireman want to save people, right? So while he is performing his duty of saving other people, will he be, putting himself in danger? Of course he will be. So we must come up with some protective clothing or outerwear for him to protect himself right now. So imagine a fireman dash into this burning house, Nikki. Okay. he cannot have his shirt easily catching fire, isn't it? He also cannot have his shirt taking in a lot of heat because the heat from the fire can cook him. Even if the clothes doesn't, melt away, okay, the heat that it's conducting will cook this guy inside the burning house. Clear or not? So therefore, there's no correlation. If I give you this example, do you think it is helpful? Yeah. So how do you spell Kevlar? You can go and Google about this. Kevlar, this is a very, very good material. Like in the army, the helmets, right? The helmets actually, in the past, is made of metal. So imagine you are fighting a war and you wear the helmet to run. It's very, very heavy and your neck will be so tired, right now, trying to balance that thing. Okay, so when they invented Kevlar, okay, these army guys, when they put on their helmet, okay, the bullet cannot penetrate this helmet, and at the same time, it is so light. Okay, they can run faster, they can support the helmet easily. Okay, Nikki, Kenna? Something that good thing you brought up, then we can actually explore it. Okay, question 11, the figure shows some representation of elements, compounds, and mixtures. Choose the letter on the diagram which represents the following substances. Each letter can be used once only. Now, before we go into A, B, C, D here, I want you to look at P, Q, R, S, T, U. Tell me about P. Tell me about P. What do you think P is? How do you describe P? Do you see that you have the white circles? There are white circles here, right? Independent on their own. Then you also have some structures that look like this. Okay, so what are these? Okay, so we know we can call this atoms, right? Okay, we can call this element as well. So if I'm looking at this one, this is a molecule. But what kind of molecule is this? Molecule elements or molecules of compounds? Okay, so think of this. So this is molecule of compound, right? Not because they are not the same elements. So how do you describe P? The way to describe P will be, it is a mixture of an element and a compound. So this is how we describe P. How do you describe Q? Ananya, your spelling today a little bit different. You cut short your own name. Yeah. So Ananya, want to try this one or not? How do you describe Q? Yeah, I know. You missed out. Was it intentional or accidental? Okay, accidental. Okay. So how do you describe Q? You want to try? This kind of question should come up for exam. I can tell you. Sure, come up for exam. Sec 1, usually they like to test students on this. So you better be good at this. Come. Okay, Tammy, can you do R? Tammy is like, her eyes open so big. Tammy, come try R. And then the next one, S, I will let Serena do it. T, Jensen. Jensen put her hand. Jensen, good. You volunteered T, you do. And then you, Mother, you will do it. Okay. So Ananya type for me already for Q. Type into the chat, send to me. Okay. All right. So I have Nikki typing something in. Yeah, these are molecules or compounds, right? And you see, they seem to be quite far apart from each other. So it is in a gas state, right? Gaseous state. Right or not? They are so far apart from each other, right? Right or not? So these are